Welcome back. Problem 6-14. This problem is taken from chapter number 6, that is bending, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the industrial robot is held in the stationary position shown. Draw the shear and movement diagram of the arm ABC if it is pin connected at A and connected to hydraulic cylinder which is two force member BD. Assume the arm and grip have a uniform weight of 1.5 pounds per inch and support at the load of 440 pounds at point C. So you can see this is robotic arm, and at point C you have a load of 40 pounds that is acting downward. The weight, uniform weight of this arm is 1.5 pounds per inch over the length of this arm, and it is pin supported at point A. It means that if you remove this pin support, so you will be having a vertical reaction at point A. And there is a hydraulic cylinder which is two force member, which is this force. It means that it applies force FBD, and it will have two component. One is horizontal and other is vertical. So you have to draw the shear force and bending moment diagram for this arm. So let's start with the solution. So first we will draw the free body diagram of the robot arm there. So we will consider as it as a beam. So for that I will consider it as a beam like this. So you can see that at point C you have a load which is acting downward, and this load is 40 pound, and the weight of this arm is a uniformly distributed load which is 1.5 pounds per inch. So this will be act downward. This is uniformly distributed load. Clear? The weight of the arm is uniformly distributed load, and the magnitude of this load is given as 1.5 pounds per inch. Clear? And at this point A you have a pin. So if you remove, you will be having a vertical reaction force which will be let this, we are taking it downward, which is RA. And at point B we have, this is point B and this is point A, and at point B we have a reaction force by this member which will be like this, and this force is FBD. This is making 120 degree over here. Clear? So this remaining will be 60 degree. And if you take these two members, one is FBD X component and other is FBD Y component, so this angle will be 30 degree. Clear? So we'll find this RA, we'll find this FBD are its component, FBDX and FBDY. Clear? And then we will draw the shear force and bending moment diagram. So for that you can see the length is mentioned over here. This length is from this point till point A, this is 4 inch. Clear? From A to B this length is 10 inch. Clear? And from this till end we have the length is 50 inch. So we'll apply equation of equilibrium. So first equation of equilibrium is that sum of all moments about point B is equal to 0, and taking the counterclockwise moment as positive. So about point B we will take sum of all moment about point B is equal to 0. So what we will do is that if you convert this uniformly distributed load into point load, so it will be this 1.5 into total length over which it acts. So 50 plus 10 plus 4 is 64. So 1.5 into 64. Clear? And this load will act at a half of this. So total is 64. So half is 32. So it will act at a half of this. So this will be act, let this is the half. For example, this is the half. So this distance will be, this will be 64 divided by 2, which is equal to 32 inch, for example. Now you can see this is 50. So this remaining distance will be equal to, this will be equal to 18 inch. Clear? And now we'll apply equation of equilibrium. So first equation of equilibrium is sum of all moment about point B is equal to 0, and the first moment will be produced by this force is 40 into perpendicular distance is 50, and this is producing clockwise, so it will be negative. So I will write first minus 40 into 50. Clear? The second moment will be produced due to this load, which is 1.5 into 64, and perpendicular distance is this 18, and this is also producing clockwise, so it will be negative. So I will write it minus 1.5 into 64 multiply by this 18 distance. The third moment which is produced due to this RA force and perpendicular distance is now 10, and this is producing counterclockwise movement, so it will be positive. So I will write plus RA into 10 is equal to 0. This force is passing through point B, so it is not producing moment because its two component will passing through this point B. So this is the equation. So when you solve this, you will get this RA will be equal to 372.8 pound. Clear? Now we'll find this FBC. So for that we will apply equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force which is acting downward is this one, the second one is this one, which is uniformly distributed load converted into point load, the third one is 40 pound, and the fourth one is vertical component of this FBD, which is FBDY. So I will write it here minus RA, which is 372.8, clear, minus 1.5 into 64, clear, minus 40 plus FBD y component. Their sum must be equal to 0. Okay, so you can now here you can see that this, if you take cos of 30 degree, so it will be equal to base divided by hypotenuse. So base is FBD y component divided by hypotenuse is FBD. So this FBD y component will be equal to FBD cos of 30 degree. So we will replace it over here, minus 372.8 minus 1.5 into 64 minus 40 plus FBD cos of 30 degree is equal to 0. So when you solve this, you will get this FBD comes out to be FBD comes out to be 587.5 pounds. Okay, we will find its vertical component, which is FBD y component, and this FBD y component is FBD y component. If FBD into cos of 30 degree, so 587.5 into cos of 30 degree will give you FBD y, and that is equal to 508.8 pounds. We do not need FBDX because while drawing the shear force and bending moment, you will have the vertical component. Now it's ready to draw the shear force and bending moment diagram. Again, I'm going to resize them in order to get the space over here. So resize it. Okay, so that we have a sufficient space. Okay, what we will do is that we will take vertical line from the end of the beam. So this is the vertical line from the end of the beam, and here, so we will take the vertical line from the end of the beam. So first we will draw the shear force, clear, and again I am going to draw horizontal line, that x in inches, here it is in inch, clear, and where V shear force is in pounds, clear. Let one division over here is, you can take as per your convenience. Let's say one division is 6, 12, and you can go on 18. Similarly, minus 6, minus 12, and so on. Now you can see that at point A, at this point you have shear force is equal to 0 because there is no load. Clear? This is the load which is 1.5 kilonewton, 1.5 pound per inch. So at x is equal to 0, 1.5 into 0 is 0. So first point will be this one. So I will choose another color. This is the first point, clear, which is 0. Now at this point, at a length of 4 inch, this is 4-inch length. 4-inch length. So at this point you can see there is a uniformly distributed load, and this load is 1.5 pounds into 4. So 1.5 into 4 will be equal to 6, and this 6 will be minus because this is downward. So till this point A, if you convert this load into a point load, so this will be, the behavior will be like this, will be minus 6. So this is minus 6, and your bending moment, shear force will be a straight line, not a curve. It will be a straight line because you can see that this uniformly distributed load is a horizontal line. So this is your first point. Now at this point A, you can see you have RA which is downward, and RA is 372. So minus 6 minus 372.8 will be minus 378. So 378, if I plot it, will be so much downward. So let assume that this point is minus 378. Assume it. This is minus 378.8. This point is minus 378.8. So your shear force will change from minus 6 to 378.8. Okay. Now again, you can see that from moving from A to B, there is a uniformly distributed load, and this is 1.5 and length is 10. So minus 1.5 into 10 will be equal to minus 15. So what we will do is that minus 378 minus 15 will be equal to minus 393.8. So at this point B, we will have minus 398.8. So we will plot, let this point is minus 393.8, and again it will be a straight line because you can see that bending moment is uniformly distributed load is a horizontal line. Okay, now at point B, you can see you have a load of FBDY which is equal to 508. So minus 393.8 plus 508.8 will bring it to 115. Clear? So assume that 115 is somewhere here, for example, because we have shortage of space. So 115 is like there. So shear force will change from minus 393 to 115. And again, you can see that you have a uniformly distributed load over a length of 50 newton, 50 inch. So 1.5 into 50 will be equal to 1.5 into 50 will be equal to 4. Let me calculate it. 75. So 50 into 1.5 is 75 at this end. So 115 minus 75, because this load is downward, will give you 40. So at this end we will be having 40. So at 40 you will, let's say this is 40. So you can this is 40 again. So you can draw it using a straight line and slope is decreasing. Okay. Now at the end you can see that you have minus 40 which will bring it to 0. Clear? And this will be like this. So this is your shear force diagram. Now we'll move toward bending moment diagram. So for bending moment diagram, I will extend it. Clear? And here you will have to pay attention because we will use a simplest method. Okay, we know that this is moment and the unit will be pounds into inch, and this length x is in inch. So first area under the shear force diagram, this area, you can see this area is rectangle, and rectangle area is 1 over 2, its breadth which is 4 and its height which is minus 6. So minus 24 divided by 2 is minus 12. So at this point you have to plot minus 12. So let this is minus 6, minus 12 and so on. So first point is minus 12. So this is minus 12. Okay, and at this point you have bending moment is equal to 0 at x is equal to 0. Now you can see that this shear force is a this shear force is a this shear force is a 1 degree line and slope is decreasing. So bending moment will be second degree curve and it will be in clockwise direction. So it will be like this. It will be like curve. So I will join these 2 points in a curve, clear, like this. Okay, this is the first area. So first area, let's say this, I will write it as A1. This area A1 is 1 over 2 into 4 multiplied by 6, which is equal to minus 6 because this is downward. So this is minus 12. Now the second area is this 2, A2, which is trapezoid. You know trapezoid is a quadrilateral whose two opposite faces are parallel, or opposite edges are parallel and two are not parallel, clear? So in this condition its formula is 1 over 2 into A1 plus A2. A1 and A2 are its parallel length into distance between them. This is, let's say, distance D into D. So by using this formula 1 over 2, it's A1, let A1 is this one, which is equal to minus 378.8. So minus 378.8 plus the second length is minus 393.8. So minus 393.8 multiply by the distance between these two. So distance between these two is, you can see this is 10. Clear? So I will write multiply it with 10. So this area A2 comes out to be minus 3875. Clear? So the second point at this length will be equal to minus 3. Let, it's difficult to go downward, so let I will assume that this point is minus 3885, 3875. This area is, this point is 3875. The unit will be pound into inch, and you can see that here the movement is the shear force is a 1 degree line and slope is decreasing, so bending moment will be again 1 degree higher, and it's second degree curve in clockwise direction. Okay, so I have to draw it like curve. It will be like this. Okay, now the third area is, again you can see this is the third area, and this is A3, and A3 is also trapezoid. So 1 over 2, its height is 115. So 115 plus this height is 40 and multiply by this distance which is 50 inch. And this area A3 comes out to be, this is positive and this comes out to be 3875. This is minus 3875 there. So at this end, okay, I have made a mistake. This I have to delete this curve. This is the point. Okay. So at this edge, we can see that this is minus 3875 and this area is plus 3875. So it will be a 0. And you can see that the slope is, this area is positive and slope is decreasing. So again, your bending moment will be second degree curve and it will be in clockwise direction. It will be like this. So this is its bending moment diagram. I hope it will be a clear. And again, if you have any difficulty, I will suggest you to watch it slowly and clear all your steps. I hope you have enjoyed this video, and if you have any question you can ask me in comment section. Do subscribe my channel and press the bell icon so that you can get notification about my latest videos. Thank you.